Hey, hello everyone. How are you? Welcome to our today's session. Now, today's session is special, right? Yeah, I think a lot of you people know Parth, Papiya, Disha, Ashwini. You are new, I think, Ashwini, right? Yes. Om. So, no resistance in excitement. Nice. It's a good statement. Yes. Top 15 questions, top 15 previous year questions. I understand a lot of you were requesting for previous year electricity questions because I understand electricity is tough, which I have seen a lot of my students were scared of electricity, right? So don't worry. Today we have questions from electricity, questions from magnetism, and the good thing is all these questions have come in the previous year board papers, which means it's a good reference point we can start from, all right? So that's why. Hey, hello, Shraddha, Sukhjot, Gungun. Excited, huh? And yeah, today's session is also going to be intense. It's a 1.5 hour session, which means what do I want first of all? Let's just be on the same page. What do I want? I want you to be first of all sitting in a position where you can straightly learn, right? For 1.5 hours. It's a long duration, I understand. Next, you should have the notebook, you should have the pen, you should have all your concepts, your attitude ready with you. You will be answering all these questions, all right? I'm there, obviously, but you will be giving the answers, all right? Yes? All ready? Nice! Let's start solving. What do you say? All right? Excited? Think of it. Why only 15? So that I can cover rest in the next session. What will we do if we finish everything in this one session only, right? 15 से start करते हैं और क्या? Oh, nice, Sukhjot. All right, let's start, guys. Let's start solving the previous year questions. And I'm telling you, all these questions, once you solve now, you'll start believing. It's not impossible. Board is something which you haven't seen before. You have done all these questions somehow in all these sessions. You'll just realize it. All right. So, electricity and magnetic effects of electric current. We'll start with electricity. How many of you are scared of electricity? Tomorrow is science exam. Nice. So this is a good thing for you. A lot of you were scared. I have read all your previous comments. I have seen many of you are requesting electricity, the circuit-based questions, combination questions. We have it all, right? And how many of you remember that mistakes we could have done, right? You'll see that. Why? The reason I'm laughing is because let's look at the first question. Come on, let's do it. The first question from electricity, CBSE 2019, 2 marks question, all right? Not long ago, 2019, all right? In the experiment to study the dependence of current I on the potential difference V across a resistor, nice. A student obtained a graph as shown. Look at the graph. Look at this graph closely and tell me I haven't warned this to you before. Hello. Come on, guys. Look at the graph. Tell me you don't know this thing. I have told you this many times. The way they'll play with the graph is, notice the x-axis and the y-axis. What is it? IV graph, correct. What else can the examiner do? There's not much to do. They can change the axis. You will be aware because we have discussed this many times in mistakes in our sessions. So watch I and V graph, right? You know all these things. First part is asking you, what does the graph depict about the dependence of current on the potential difference? Fine. Second is, find the current that flows through the resistor when the potential difference across it is 2.5 volts. Whenever, it's okay V and Tech, we are not, this is the first question. Nice. I can see answers coming up. So whenever you see such kind of a question, read both the parts. Start solving part by part, right? Start taking a very keen look at the first part. And first of all, I have told this many times, read it patiently. Don't be in a hurry to solve these subjective questions. Let's start with the first part. What does the graph depict about the dependence of current on the potential difference? All right, you have the graph, right? Correct, I can see. Disha, nice. Very good. Sukhjot. Hey, Abhijit. Yes. Simple, right? It's a straight line. I understand it's an IV graph, but still it's a straight line, right? So what does this mean? It means at constant temperature, the potential difference is directly proportional to the current. Before you gaming, give answers, your name will be taken, man. This is the deal we have in our session, right? Come on. Good questions, good answers, and names there. Nice, nice, Charvi. Hey, Anu, Rashi. Come on. Yes. Directly proportional. Something is visible, right? It's visible on the graph, very evidently. Fine. So, we can say the answer would be the potential difference V across the two ends of a conductor / resistor, right? Thank you, VNTech. Yes. Nice, Sukhjot. Swaroop, very good. Yeah, that's a good thing. 1 by R is the slope. Nice. Alright. It is directly proportional to the electric current I flowing through the conductor at a given temperature. हमको statements का भी ध्यान रखना है. We have to take care of how you are writing the answer. Fine. This is something which I have repeated many times. English, Hindi, whatever you understand, you are comfortable with, don't worry. But focus on the concept. है ना? Potential difference V across two ends of a conductor / resistor still fine is proportional, directly proportional to the electric current flowing through the conductor at a given temperature. Given temperature is an important word over here. Mind it, guys. A lot of times I have seen students forgetting this. That potential difference is directly proportional to the current. That's it. No, at a constant, at a given temperature, right? Nice, Srishti. Om, very good. Arey wah, Papiya. Om, nice. ठीक है. 1 mark is ours. एक number मिल चुका है अपने को. Let's move forward. Find the current that flows through the resistor when the potential difference across it is 2.5 volt. So if you were to make mistake in such kind of a graph, I understand. The first part you would have done. That part does not need to understand that I is on the y-axis and V is on the x-axis. This part does, right? This part needs understanding. Why? Because you are about to find the slope and someone, I think Sudarshan wrote that, 1 by R is the slope, right? R equals change in potential difference upon change in current, V upon I, correct? So formula would be I equals V by R. Now if you are finding slope, it's a straight line under normal physical, yes, nice Jia, correct. Other physical conditions, biologist, I would say just focus on temperatures, right? Correct, nice. I can see answers coming up. Alright. So, if you were to find the slope, what you would do? V, right? This will be change in, come on. Yes. Mind it, guys. Language before you gaming. Focus on the session, guys. Come on. Yes. V upon I you have to find. But what is there? I upon V is given to you. Means I upon V is 1 by R. So you can find the slope, right? 0.1 upon 1 is what? 1 by R. So R is what? 1 upon 0.1. That is 10 ohms, right? Correct? And same thing you can do with 4 also. There is no problem in that. Why? Because it's a straight line. Slope will be same. That's why. Alright. So resistance you found by yes, correct. Nice. 10 ohms is the correct. Yes, it's right. 0.25 ampere. I think you mistyped over there. You will find first of all the resistance, that is important, and once you have found the resistance for voltage that is 2.5 volts, you can use the formula I equals V upon R, that is 2.5 volts upon 10 ohms, that is 0.25 amperes. So that's why it was an easy question. Hello Sonam. Current is 0.25 amperes. So that is the correct answer. All clear, right? So I'll tell you one more thing. During the question, give me the answers and ask the doubts once I'm done with the question. All right? Nice, Muralidharan. That's the right answer. Ohm is the unit. Omega is the symbol. Right, Sushti? Alright. Little bit tricky. No, it's not that tricky. Muralidharan, I took your name. Can we solve this question by only looking at axis? You can, but you know what, Ayush? It's a subjective exam. That's why I want you to understand what steps you are going to write. That's why. Solving you can do. If it was an objective exam, I would have said take the shortcut, not a problem. It is a subjective exam. That's why. Yogi, same thing, the same answer for you. You can find it, but you should know how to write it. Oh, Hari Murli, sorry. So the name which I see there, that's what I take. Sorry. All right, come on. Next question. First question is done, right? Quite easy question. Next question. You know what? This is a good question. Shivani, the question was, there was a graph given to you, right? And you had to find, first of all, resistance. It was an IV graph. You had to find resistance, that would 1 by R. The slope would be 1 by R. You found the resistance. V was given to you. R you have found. You have to find I. Simple. Right? Maria. Names are fine, guys. Come on. Ask good questions. Give good answers. And you know what? Names will be taken. That's how we roll in this session, right? Come on. How did I find resistance? By finding the slope of the graph. Come on, guys. Start giving me answers for this question, and I'll just clarify this small thing to everyone. All of you who are asking how did you find the resistance? This was an I, this was V, this was a straight line. This is the slope, right? This is the slope. This is what? Change in V. This is what? Change in I, right? And you have to find resistance. It is what? Delta V upon delta I. Simple, right? Cool? Oh, it's okay, Yogi. Don't worry. Big things are coming up for everyone. Ha, nice. It's a good thing. I'm getting answers. And you know what? The reason this question is important because I'll ask a poll on this. Don't worry. So, I'll give this question to you in a poll, right? I'll give you 30 seconds. Fine. 4 options, and I want to see how many of you are giving the correct answer. The time starts. Come on. Time starts. Now, I'll give you 30 seconds. Come on. Do we have the poll running? Yes. Come on, guys. A, B, C, or D? You can click it on the poll. Oh, Sukhjot, nice. You have a good typing speed, man. Nice. Okay. B is 56%. Alright. B and C had a fight. I can see that. I mean, A and D is still fine. B and C had a fight, right? Unable to understand the question. Srishti, believe me, I'm glad you said that. I'm glad you said that you are unable to understand the question. The reason, I'll tell you. The whole game of this question is, in this 2 words. Wire is doubled on itself. What does this mean? So, you have heard the length is doubled keeping area constant. The area is doubled keeping length constant. You have also heard the wire is stretched keeping volume constant. But we haven't heard this word, right? Hai Srishti, focus. So, you haven't heard this word. Wire is doubled on itself. What does this mean? If we understand this, this question is done, right? Don't worry, I'm explaining. Imagine, there is a wire with length L and area A. Fine. You know the resistance. R equals rho L upon A. We are fine with this. Now, what does this mean, doubled on itself? Can someone tell me? This was the wire. Sorry, let's say this was the wire. You folded it. And this is what we mean, doubled on itself. This was the wire. It is doubled on itself. So, what does this mean? It had area A. Now the area is doubled and length is halved. So that's what it means. Nice, Rishit. Very good. Yes, Papia. So yes, what does this mean? It is folded from the middle. So it's just a, what do I say, a smarter way of asking a question. The examiner is trying to get smart. Simple, right? So this is what is happening over here. Yes, length was halved and area of cross section was doubled. That is the clue. That is the whole game for this question. Apart from that, nothing is there. Nice. Yes, Hari Murli. Correct, Charvi. Yes. Rudra, slightly late, but not that late. Alright, so this thing is clear to everyone? Fine. Now, what is there? Come on. Resistance is rho L upon A. It was 6 ohms. We know that because it is given in the question. Now, when the wire is doubled on itself, what do we mean by doubled on itself? It means the wire is folded from the middle and made like this. Means area got doubled, length got halved. Simple. So that's why length is L by 2, area is twice of A. And then if you apply R equals rho L upon A, so rho into L by 2 upon 2A, and we all know this is what, 1 by 4. So it becomes 1 by 4 times of the previous resistance. 1 by 4 times of rho L upon A, that's why 1 by 4 into 6 ohm, that is 1.5 ohms, and that's the answer. Yes? Come on. Guys, note this word. I'm telling you, it's a very important word. Tomorrow it can come. We have never done this. A wire is folded or doubled on itself. This is a new thing you have learned today, right? So mind it. Correct. Yes, 1.5 ohms is the correct answer. So this was a good question. Fine. All right. Nice. Today we learned something new. At least this doubled on itself wala thing. It's a new thing which will not mess with us tomorrow. Nice. All right. Yes, Selena has good questions like this. 3 2 ohm resistors A, B and C are connected in such a way that the total resistance of the combination is 3 ohms. Now these questions we have done. Thank you, Rishit. Nice, nice, Disha. Correct. OS. All right. Ha. Thank you, Navjot. I try that. Right? Show the arrangement of the 3 resistors and justify your answer. See, I understand. With practice, these questions become really easy. Right? 2 ohm resistors, 3 resistors, I have to get 3 ohms, right? So I'll start with this thing. And you know what? In exam, how will you do it? If you struggle, this is my answer to all of you. If you struggle with such questions, now I would suggest you, if this is your notebook, right? Just do some rough work here. Do some rough work. Think, if I connect them in series, I'll get 6 ohms, right? This is 6 ohms. If I connect them in parallel, what do I get? What do I get? 1 by 2 plus 1 by 2 plus 1 by 2 is 1 by R. So what do I get? 3 by 2, that is 2 by 3. This is the R. Fine. Simple. Nice. That's my batch. Good answers. Very good. Nice. Trial and error. Yes, Yogi, you are right. But this trial and error could be smart. I have seen some of you giving the correct answer very, very quickly. You'll get better. Shahid, what happened? OS, sorry, I can't. We are doing this live. It's free. Come on, focus. Focus on questions right now. Hello, Prakash. Thank you for joining. Right? So, parallel is also fine. We understand it is not possible. Fine. Let's try one more combination. This is one more combination, right? It's also possible. I mean, if you take two ohms resistance, connect them in series and connect a 1 2 ohm resistance in parallel. So what will happen? 2 plus 2 is 4. Now this is 4, this is 2. So equivalent will be 4 multiplied by 2 upon 4 plus 2. That is what? 8 upon 6. Not what you want, right? Right? Spamming, huh? Oh, yeah, I'm explaining. It's not done. The explanation is not completed. So I'm just telling you there are different trial and errors which you can do. So when you did all those things in your rough work section of your exam notebook, then you realized this one is working. How do we know? 2 ohm and 2 ohm in parallel. So this is what? 2 multiplied by 2 upon 2 plus 2, or you can also do 1 upon R equals 1 by 2 plus 1 by 2. This is what? 2 by 2, 1 by 1. So R is 1 ohms. Simple. All this thing is very easy for you, right? Now this equivalent is 1 ohms and 1 plus 2 is 3 ohms. This is how you be better at this, right? Fine. Oh, it's okay. It's okay. Yes, nice, Rishit. This is how you make, what do I say, a clues in your mind. Yes, correct. Nice, Disha. Yasharth, very good. Nitesh, Namish, Krunk boy. All right. Now, one more important thing which I want to just tell everyone you, and a lot of you know this already, is make diagrams. It's okay, I understand it's a chat, but when you are answering this question in the exam, make sure you draw the diagram. That is a very, very, very good practice. You will show exactly what is happening, what the diagram you have chosen. You don't have to do all the combinations. Okay? I just want to be clear here. Sara nahi karna hai. Don't make all the combinations and say, sir, this one is working. No. Use the correct one, but explain it again. Solve it. Isko banayenge. Then what we'll do is, equivalent is 2 and 2 is 1, 2 and 1, and that is 3, and hence the combination is this one. Simple. Hai na? Nice, Ashwini. Good. Thank you, Kavya. Yeah, Rishit. Point taken. And Rishit has a good point over there. Right? If it is more, I mean, we know this, right? In series, resistance increases. In parallel, it decreases. Now, 3 was between. Series would have been 6 and parallel would have been 2 by 3, which means it is between. So that's why it's a combination thing. Shakti. It's a good thing, I would say. It is necessary to draw diagrams. Then it will be on the mood of the examiner. I mean, if you made sense with all your statements, then fine. But still, it's a very good habit. If you make the diagram, it's very clear. Student knows everything. All right, fine, full marks. What do we want? We want to get full marks without a lot of effort. That is a good thing, right? Fine. Thank you, Srishti. Take care. Question number 3. Come on. CBSE 2018, 3 marks. Yes, Priya, you must make some rough diagrams. CBSE 2018 and 3 marks, right? 3 number ka question hai ye. Let's take a look. Come on. Mode of. Mode of. Come on. Get in the mode of question answering. Come on, guys. Next question. Next question. Mentos method. Mentos method iska yahi hai. If you do the diagram first, right? Rough, do the trial error, make the diagram and solve it. That's a very good and, I would say full number getting method. Yes, come on. Write the relation between resistance and electrical resistivity of the material of a conductor in the shape of a cylinder. Now guys, one more thing, I have told this many times. Whenever you are attempting a subjective question, read the question patiently. Panic nahi hona hai usko padhte hue, right? Read it patiently. Write the relation between what? Resistance and electrical resistivity, alright, of a material of conductor in the shape of cylinder. ठीक है? It's a cylinder of length L, area of cross section is A, and then what is the question asking you? है ना? What is the question asking you? Kashif, I got your answer in 1 or 2 comments only. Yeah. Yes. Correct, Sukhjot. Nice. Yes, Ashrita. Question is asking you to derive the SI unit of electrical resistivity. Right? Nice. Nice, Harimurli. Sandhya, good. Ohm, meter. Yes. Yes. Nice, Yogi. We have derived it. How will you derive it? We'll start with the formula. R equals rho L upon A. And I don't need to tell you all these formulas are important. I hope you have your formula sheet with you, right? So, this is the formula. Fine. How will you write the answer? Resistance of wire R is directly proportional to its length L and inversely proportional to its area. Fine. So, you have said R is rho L upon A. Then you just made some adjustments. Screen is not visible. Srishti, I would say refresh or change those the video settings. और कोई ये I don't think for anyone else this is the problem, right? हाँ, ohm meter, that's true. So rho equals RA upon L. So I'm telling you, this was a little vague question. I mean, derive first and then tell what is the SI unit. So how will you derive? You will start from resistance, right? Resistance कितना होता है? R equals rho L upon A. You will make some arrangements. You will say rho equals RA upon L, and then you will put the units. By resistance का unit resistance is ohms. So you will write ohms multiplied by meter square upon meter. It will cancel out and it will give you ohm meter. Simple, है ना? That is enough. Correct. Ohm meter. अरे nice दिशा, रोशनी. Screen is not visible. I think refreshing or changing the or you can just try joining back. Don't worry. Right? Guys, is anyone else facing the problem with the screen? Just let me know. Roshni is facing and nice, Nitesh. Kashif, yeah, got your point. Nice. Yes, Srishti, you are correct. So, first part is done. Simple. Yes, Nitesh, right, correct. Oh, thank you, Maitri. Blur, I feel na, it's because of net issue only here. Alright, come on. Next question. Part B. Resistance of metal wire of length 5 meter. It's a straightforward numerical. No vagueness, just values, a formula, and the answer will be there. And I think we have got the answer, right? Thank you, Tanmay. Right? We have got the answer. Come on. Resistance of metal wire. Length kitna hai? Length is 5 meter. Resistance kitna hai? It is 100 ohms, right? How much is the resistance? 100 ohms. If the area of cross section of the wire is 3 into 10 to the power of minus 7 meter square, area is given to us. Nice, Papia. Yeah. Alright. Nice. Yogi, Ananya, Disha. Very good. Kashif. Very good. Arey yaar, badhiya. Formula used. R equals rho L upon A. Simple calculation, mathematics. Just be very careful with the calculation mistakes, alright? So I'll tell you where the calculation mistakes can happen. So as a student, I would say R equals rho L upon A. ठीक है. Alright. So rho equals, I have to find resistivity. Rho equals RA upon L. Fine. R is 100 ohms. A is 3 into 10 to the power of minus 7. Note the value correctly. यहाँ गलती मत करना. So, right, I'm telling you, these mistakes we have discussed. In putting down, in taking the value from the question, minus 7 को minus 6 लिख दिया. So these things. That's why I say, be patient. सब हो जाएगा. Don't panic. And upon 5 meters. Why? Because the length is given to you as 5 meters. Simple. 5 and this is 20. Right? 3 into 2 is 6. And this is what you get. Simple. Right? Straightforward. Yes. Too easy. Nice. Minus 7, minus 5. Arre. Rita, minus 7. No. Rita, you made mistakes in that thing. This became 20 into 10 to the power of minus 7. So this is what? 0, right? Means 2 into 10 into 10 to the power of minus 7. So 10 into 10 to the power of minus 7. क्या हो जाता है? Plus हो जाता है ना? 2 into 10 to the power of minus 7 plus 1 is 2 into 10 to the power of minus 6. Right? See, this is an example only. The answer is 6. I'm just giving you an example of this. Alright? Fine? Yeah, Yashar, you can do that. Halwa sawal. Yes. Alright. Next, combination of resistances. As requested, one more question from CBSE 2018, 3 marks. 3 number का सवाल. Let's look at this. बहुत हलवा खाएंगे आज. Come on. Yes. Hey, Namish, the thing we are doing right now, interacting, practicing previous year questions. So you practice these questions here right now diligently, and I would say practice is the only key right now. Don't worry. And we'll also come up with strategies. Don't worry. Tips तो बहुत हैं यार. But right now I don't want to give you any tips. We want to practice, है ना? ज्ञान बहुत हो गया. Let's talk action now. Come on. Nice. For the combination of resistors shown in the following figure, find the equivalent resistance between M and N. Nice. Yes. Yes, maths and physics are same. Maths is the language of physics. You have an idea in physics. How would you put on paper? Maths. Nice, Kavya. Yes. Powerful tips. Don't worry, Khushi. We'll come up with powerful tips. We'll have a session on this, yeah. Don't worry. Thank you, Danny. All right, sir. Come on, come on, come on. Chaliye, sir. Come on. M and N. What do I see? All right. It's a combination of resistance. I'll just simplify it. Fine. Second is Joule's law of heating. Why we need a 5 ampere fuse. And why is it impractical to connect an electric bulb and an electric heater in series? So do you see, for a 3-mark question, there are 4 parts. है ना? So understand, कितना लिखना है? It's not like 4 parts are there, I'll write stories in this. So be careful. है ना? I'm just letting you know so that you can see in the exam, अरे तो 3 marks का है and there are 4 parts. I'll choose. I won't be just wasting a lot of time on each part. Right? ठीक है? So let's start with the first one. Combination is there. You have to find between M and N. Here is M. Here is N. Alright. So first thing I want to simplify is, and I think you have already done. Nice, nice, Hari Murli. Nitesh, nice. Oh, 5th class, huh? Man, brave. R3, R4. So these are in parallel. So what will you do? You'll simplify that first, right? So Rp will be 1 upon Rp equals 1 upon R3 plus 1 upon R4. We'll simplify it, right? So Rp will come out to be R3 into R4 upon R3 plus R4, right? Right? Oh, nice here. Very good, Kavya. Yes, yes, that's right. You can just simplify that 1 upon R3 and 1 upon R4 a little more. Otherwise, yeah, that's good. Nice, Kasha. इस क्वेश्चन में करना क्या है? इस क्वेश्चन में सिंप्लीफाई करना है. दैट्स इट. और कुछ नहीं करना है. तो आर इक्विवेलेंट क्या हो जाएगा? R1 प्लस R2 प्लस RP. सिंपल. हाउ विल यू राइट? द क्वेश्चन वाज इसमें करना क्या है? ये करना है. पहला डायग्राम, सेकंड डायग्राम, एंड यू विल सिंप्लीफाई इट. RP equals R3 R4 upon R3 plus R4. Equivalent will be R1 plus R2 plus RP, and you will write this final resistance. That's it. ठीक है? Ananya, directly proportional. Joule's law of heating. Hey Arindam. मिलेगा, formula sheet मिलेगा. Don't worry, don't worry. Don't worry, guys. Got it? Nice. Second, Staley's Joule's law of heating. So whenever this Joule's law of heating thing comes, we should think of I square RT. Right? I square RT. So, which means heat is directly proportional to square of current, directly proportional to resistance, and directly proportional to time. Simple. Square of current, resistance, and time. How will you write it? Nice, Kashif. That's pretty good. Yes. Yes, correct. Diagram is good. Necessary. See, if you write the answer, you might get marks. But the reason I'm saying might is, अगर नहीं समझ आया. अब होता है ना यार, examiner also they get frustrated looking at so many copies. So they want something which is nicely looking and clear. That's why I say diagrams are good. Yes. Joule's law of heating states that when a current I passes through the conductor of resistance R for a time t, then heat developed is equal to product of square of current, resistance, and time. So what we have done basically, the formula I square RT, you just have created into a paragraph. Word, right? Nice, Harimurli. Very good. Yes, that's right. Okay. This is a good question. Yes. Any two things constant? Ananya, you're right. Two formulas. But this I square RT is a specific name given to you, Joule's law of heating. तो इसलिए उसको लिखते हैं, right? It's interconvertible, no? I square RT को आप V square by RT में convert कर सकते हो, right? VIT को आप इन दोनों में convert कर सकते हो. So these things are there. But I square RT is specifically the Joule's law of heating. Yes. Getting half marks is unfair. Yes. But you will have to write the complete law. Huh? Alright, come on. This question. Oh, nice, yes, Sukhjot. Very good. You got it correct. Oh, Papia. Sorry. Nice. Very good. Alright, so let's start. Let's solve this question. See, I won't explain you why we use electrical fuse. It's a safety device. If current goes more than a certain limit, it will melt down, right? That's true. Fine. Heating effective electric current is the concept. Why? Because the wire melts because of heat only, right? Fine. It works on Joule's law of heating, I square RT also. That will also fine. Yes. Nice. Correct, Charvi. Yes. Mythical YT, general gyan. Focus, answer. Yes. Power consumed is P equals V into I. Now let me ask you. The reason I'm seeing these quick answers is because you have been given the power, 1 kilowatt. You have been given the voltage. You can find the current. No. How? P equals V into I. Do you have to go into a loop of finding the resistance, finding anything else? No. Why? Right? So let's find, yes. So Ananya, it's the name of that law. When you state something as a law, it starts with experimentation. We experimented, found it is square of current, it is R, it is T. That's how it comes. Right? Come on. So, first of all, you will find the current, which I can see a lot of you did. A lot of you found the current as 4.54 amperes. Now, nice, Sukhjot. That's a brilliant answer here. Very good, Charvi. So, fuse will melt if it is above 5 amperes. That's fine. But you know the question, the language of the question, focus. Why we need a 5 ampere fuse? So, but the question kya puch raha hai? Question is asking you, if the current rating of this iron is 4.54 amperes, why are we using a 5 ampere fuse, right? That is the question. So 4.54 ka kyun nahi use kar rahe hain? Because that is the limit. I mean, that is required. Whenever you try to open or turn this appliance on, this electrical iron, it will take 4.54 amperes, which means the fuse should be slightly above, which means it should be 5 amperes. That's okay. That's fine, right? Correct? समझ में आया? Current कितना चाहिए उसको? How much current is required? 4.54. So you will take a fuse which is slightly higher so that this appliance can work. Fine. Fuse should be selected such that rating is slightly greater than maximum current drawn in the device. Thus a 5 ampere fuse is needed. Alright? Good. Nice here. Very good. Good answers. Correct. Disha, Harimurli, Srushti. More resistance can obstruct use of. It's a little out of context for this thing. Very good. Alright. This is also an interesting question. Why is it important or impractical to connect an electric bulb and electric heater in series? Electric bulb and electric heater in series. So general answers I understand. You guys will be able to answer. Yes. Yes, Kashif. Your comments are actually in bold, so I can see them very clearly. And you are giving good answers, don't worry. Yeah, I see it. Nice, Isharth. Sukhjot, very good. Yes, Swaroop, that's true. I can see Srishti. Okay. Srishti, you are touching it somewhere. Nice. Good try. Yes, Ayush, you are also right. Very good. All right. So I'll explain this to you, right? Let's analyze this practically. The question is saying it is impractical. Let's analyze this then. right? How will we analyze this? So let's say if I take a bulb of 10 watt and 220 volts and an electric heater of 1 kilowatt and 220 volts. With this rating, I can find the resistance. I'll find the resistance as 48.4 ohms and 4840 ohms. Shocked, huh? Bulb has so much resistance. All right. Then what will you do? The total resistance, its current rating will be, this is power, this is voltage, it will be 4.5 amperes, it will be 0.045 amperes, right? How do you find it? Power and voltage. All right. Total resistance would be how much? This plus this. This is my total resistance. All right. Guys, we are analyzing it, right? Okay. Question ye nahi hai. I'm doing this so that you can understand it. What will happen? Yes, Rita, very good. Nice. Nice, Harimurli. Oh, wow, Puneet. Hey, hi. So, this is the total resistance. The current would be 0.045 amperes. Now, notice, bulb ko kitna chahiye tha? How much did the bulb require? 0.045. It is getting 0.045. It is working. Fine. But heater, kitna chahiye tha? How much it wants? 4.5. How much it's getting? 0.045. It will not even work. Yes. Yes. So that's why I'm saying this is the analysis. Now, general statements are fine. So based on this analysis, what can you do? And guys, I'm giving you lot more points. 2 points are enough. I'm telling you because you can just understand what can we do. Nice, Disha. You are right over there. Very good. Sukhjot, yes. So, answer would be, it is impractical to connect because as the heater and bulb have different values of resistance and the potential will drop according to resistances. They need currents of widely different values for proper operation. If one appliance fuses, other will also fail to operate. This is the easiest one. With everything in series, this is a problem, right? Since effective resistance increases, value of current and hence power consumed by each appliance decreases. So these two are actually common for anything in series, right? Arey, you know everything, yaar, Nikhil. Why are you saying? Right? Hey, Baba. Correct. Nice. So, fine. Got this question? All right. Next question. CBSE 2018 again. So, do you see how many questions came into 2018 from electricity itself? We have done what? I think 3 or 4, right? Yes. Yes, Yashat. So, commonly, see, I did the analysis for your understanding, but the answers are telling you that it's a common thing. Whenever someone says, why not connect the circuit in series and why connect in parallel, the answers would be common. You can use them, alright? Hey Adarsh, hello. हाँ 2018 से 4 हो चुके. Yeah, right, Harimurli. So that's the thing. So many questions came, right? Alright, okay. Oh, Akshobhya, you are from 7th, huh? Wow. Nice. Come on. Oh, I am getting answers also. Compare power used in 2 ohm resistors in each of the following circuits. Come on, come on. Yes. All right. Kashif, I see your answer. बस पढ़ाने में चले गए बाल. Hey, Puneet. All right, okay. Come on, let's see. First one. Now, this is again a question which I have seen a lot of you struggle because which formula to use, hai na? This is one problem which I have seen. Yes? Hello. अरे गाना नहीं लिखना यार. Yes? Come on. Both the powers are same. All right. See, I don't know. Let's check. First of all, formula. Hey Rahman. Hey Puneet. You will find the current in series. Why? You have to find the power used in 2 ohm. Where is 2 ohm? This is 2 ohm. This is 2 ohm. All right. If I want to find 2 ohm, the power in 2 ohm, what can I do? I can use formula as I square R. I can use formula as V square upon R. Right? Correct. All right. So, which one will you use? Anyways, you have to find current. No. Why? It's a series. 2 plus 1 is 3. Current is 6 upon 3. That is 2 amperes, right? 6 upon 3, that is 2 amperes. You got the current. Then you will use I square R. In the second one. Yes. Come on. Come on, come on, come on. Yes. In the second one, you want to find the power. Now, the good thing is, I would not advise you to find the current because this is 4 volts. Now, it's a parallel combination. In parallel, the voltage remains same. That's why this and this is going to be 4 volts, right? It's 4 volt in both. It is also getting 4 volts. It is also getting 4 volts, which means you can use the formula V square upon R directly. You will get, right, 4 square upon 2. So that's why. What will be the answer? Come on. 8 watts. Nice. So 3 ohm, you found the current. Second one, you got the power directly, V square upon R. Then you found I square R. So that's why it is same. You are right. Nice. What about the next one? What about the next one? Come on. नहीं कोई prank call नहीं करना है. Come on. Yes, yes, yes. Resistance of a resistor is reduced to half of its initial value. In doing so, if other parameters of circuit remain unchanged, the heating effects of the resistor will become. I'm telling you, it's a good question. Try to answer it the best you can and we'll discuss it. Come on, it's a poll question. I'll give you 30 seconds. Your time starts now. Yes, come on. It'll become 2 times, it'll become half, 1/4 or 4 times. Okay? Yes, yes, yes. Okay. Other parameters of the circuit remain unchanged. This is the crucial statement. Thank you, Study Ju. Yes. All right, all right. A, B, C, A, B, C. The answer is A. Now let me tell you, people who got other options. Poll is not there, huh? Poll nahi aaya. Oh, sorry. Technical problem. Guys, focus on the session. Yes. So, let me tell you the answer. Why? Because resistor is reduced to half its initial value. There is no problem. There is no ambiguity. इसमें कोई confusion नहीं है. Yes. Nice. आ गया ना? हाँ, ठीक. All right. There is no ambiguity in this question, in the first statement. The problem is, in doing so, if other parameters, what other parameters? Let me tell you. Current or voltage? Which one? It's okay, Shivani, I'm asking you. Huh. Nice, Mythical. YouTube. Go on, tell me. What other parameters? Nitin, focus on the session. Hari Murli and Srishti. I see 2 answers, current and voltage, right? It's an easy question, na, Kavya? So I'll tell you. Focus on voltage. Thank you, Abhishek. All the parameters. So I'll tell you. Current voltage mein fight hai na? I understood. A lot of you are thinking current change करें कि voltage change करें या फिर current constant करेंगे voltage constant करें. I'll tell you. Yes है ना? यही problem था ना? ठीक है. So understand this. एक resistance है, एक cell है. This is V, this is I, and this is R. ठीक है? Fine. Now resistance is reduced to half of its initial value. Resistance is now R by 2. This will be V na. So what will change? Current to change ho hi jayega. Now if the current was I over here, I was V upon R. Here I is V upon R by 2. I change ho gaya na. Right? Yes. You can. You are using Joule's law of heating only. But I'm telling you what the problem is. If you believe that current is not changing, it is changing. What is constant? Voltage is constant. Right? Got this thing? So it's a very important point and very big confusion which I have seen, and that's why I wanted to clarify this. Okay? Fine with this? Understood? Nice. This is important. So that's why the answer is heat dissipated is V square upon R into T, because voltage is constant, and if voltage is constant and resistance is halved, you will get 2 into V square upon R into T, which means twice. So heat dissipated will become 2 times, and that's why the answer was A. Fine. Thank you. Nice. Correct, Sukhjot. Very good. I'm glad. So repeat, Momani, what I said was because current change hoga. The current will change. Why? Because your voltage is same, but resistance is becoming half. So that's why current will change. You can't help it. What remains constant is voltage. That's why. Oh, it's okay, Srishti. Series circuit 1. What aasan tha. Don't worry. In the end, I'll tell you. Just let me know which question was it. Series circuit. Okay. Thank you, Namish. Yes, why are heating elements of electric toasters, electric irons made of an alloy rather than pure metal? Oh, nice, Rishabh. Very good. Correct, Srishti. You are right. Wow. And if you remember, we have discussed all these in the session, right? Sab discuss kiya hua hai. Hey, Pratyush. Nice. Arey wah. I'm getting all good answers. High resistivity, high melting point, and do not oxidize and burn at high temperature. I don't want materials which get oxidized. What is the use of using them? So that's why. And this is what? Nichrome, right? We use nichrome, if you remember. Nickel, chromium, nichrome, right? Yes. High resistance, or you can be more specific. High resistivity, do not melt, and do not oxidize. Fine. Yes. Good. Hey, blink, Blackpink. Alright, so how will you answer? Coils of electric toasters, electric iron made of an alloy due to following reasons. First, resistivity of an alloy is higher than that of pure metal. At high temperatures, alloys do not oxidize. Fine. And they have higher melting point. Motivation, dekho. What is happening? Your boards are coming. I understand. Motivation is, there's nothing. Motivation something, it's not nothing. I'll just give it to you and you will take it. Wah, maza aa gaya. See, this comes with what we are doing. This is motivation. We are solving problems. I'm explaining you stuff, and we'll have a session again on Monday in which I'll be talking all these things. What is going on in our life, how to take care of us, and how to study for the boards, right? आज questions पे focus करते हैं. Don't worry. Motivation में जब कभी दे सकता हूँ. Fine. Guys, focus. Yes, motivate yourself. Nice. Fine. Question number 8. Come on. Last question from electricity. Electric bulb is rated at 200 volts, 100 watt. What is its resistance? Easy. 2025 mark question. Now focus. This is 3-part question. It is 5 marks, right? Yes? Nice. Oh, nice, Kavya. So, did you see this? There are 3 parts and it is a 5-mark question. तो तुमको ये देखना पड़ेगा how much you have to write. You have to be very clear now. ठीक है? Extra भी नहीं लिखना है. It doesn't mean you have to write extra. No, but point to point, but be very crafty in answering this question. So let's start. Come on. Power rating is 100 watt. Voltage rating is 200 volts. What is its resistance? Simple formula, right? Nice, Kashif. Very good. Rishabh. Yes, nice. Yasharth. Oves. Oh, badhiya. So, V square upon R, simple, right? Power rating is given to you, voltage is given to you. So, V square upon R, and you will find that as 400 ohms. Simple. 2 marks. Alright. Easy, nice. Calculate energy consumed by 3 such bulbs if they glow. This is a good part. Why is it? I'll tell you. Nice, Sukhjot, good. Nice. Disha, Om, Isharth. This one is a good question. I'll tell you why. Oh, Shadab. Today I'm not sure, but yeah, I'll look into it. But this video will be there, na? All these questions will also be there. And I would say whenever you want, you can take screenshots. I mean, for now. I'm not sure if it is there right now or not, but I'll keep this in mind. Alright. So, by 3 such bulbs, what is electrical energy? It is kilowatt hour. We know this, right? Correct? Nice, Ayush. You are getting there? Wow, Disha, that's important. That is an important thing. Yes, 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 very good. Swaroop, 90. Yes. So, power consumed is 100 watt. This is one bulb. 100 upon 1000 is 0.1 kilowatt. By 3 such bulbs means 3 into 0.1, which means 3 into 0.1, and it is used for 10 hours each day. This is not said, but we know this. The language is telling you this. Language yahi bata raha hai. 10 hours per day use hua hai. So it is 10 hours into this. It will be 3 kilowatt hour per day. Now it's the month of November, which means we should know how many days are there. So yes, you were right over there. And I hope you all know this. If you don't know this, so bachpan mein there was a tarika. January, Feb, March, April, May, June, July. All the risen ones, knuckles are 31. All these depressions are 30. So this you can do. है ना? अगर किसी को नहीं पता है तो. Fine. Nice. So 90 units. 90 kilowatt hour, 90 units. Alright? Good. Calculate the, है ना Charvi? You know that method. Nice. I mean, my parents also taught me like this. So I still use it if I tell you the truth. Calculate total cost if the rate is 6.50 per unit. Simple, yeah. You have found 90 units, you know the price, you will multiply and get the answer. Nice. Good. Rupa, practice. And don't worry, we'll do more questions. Nice, nice. Very good, guys. Very good. So electricity is done. Feeling confident, है ना? Rupa, don't worry. You'll get there. Do more practice. Feeling confident with electricity. Let's move to magnetism. Oh, so stretch, guys. Stretch. 7 more questions to go, है ना? Yes. 7 more questions to go. Stretch. Shake yourself. Let's start. है ना? Now your favorite chapter. Come on. Oh, nice, Suhani. Magnetic effects of electric current. Come on. First question. A big looking question. All right. Yes. Let's do it. Come on. Oh, Surya. I mean, I saw the name there. My bad. Nice. You have picked your favorite chapters, electricity or magnetic. I don't know why people hate electricity. It's good, yeah. Right? Come on. Question. Draw the pattern of the field lines of the magnetic field. Now, do you see the language? Sometimes language tend to be confusing. Draw the pattern of the field lines of the magnetic field around a current carrying straight conductor passing through and held perpendicular to a horizontal cardboard. If you understand this whole statement, it's a big statement. What does it mean? एक सीधा current wire है. There is the current carrying wire which is straight and current is, come on, tell me. Current is around the current carrying straight perpendicular. Oh, it's not still given. It's just there's a current carrying wire and there's a cardboard held like this, है ना? Simple. State right hand thumb rule and explain how this rule is useful to determine direction of magnetic field in the above case if the direction of current is vertically downwards. So do you understand this? Formulas electricity mein. Formula sheet, Sherwin. I told you. Pick a A4 sheet and write all the formulas and have a habit to look at it. है ना? Nice, Disha. Very good. Very good, Sukhjot. Charvi, Devi, wow. Kashif, बढ़िया. All right, Bhagyavardhan, nice. Abhishek, very good. Can you break down the question? See, this is what I'm doing. Breaking down the question. Look at it. Draw the pattern of field line. This is the whole question. Draw the pattern of field line. कैसा है? Situation क्या है? What is situation? It is straight conductor and a cardboard, right? A cardboard is held perpendicular to. Straight conductor is there and there is a horizontal cardboard perpendicular to your current carrying conductor, like this. This is the whole statement. Then the question is asking you, right hand thumb rule, explain how is it useful, and direction of current is vertically downwards. इतना ही है इसके अंदर. Fine. Let's do question. Nice. Fine. So question is clear now. Which rule? Thumb rule. कैसे? Current, magnetic field lines. Current and magnetic field lines. Simple, right? So you can just visualize this. Right hand thumb rule. We all know this, right? Nice, Yasharth. That's a good statement. So, how will you answer it? You will draw the diagram again. My recommendation is draw the diagram if it is making sense, and here it is making sense, right? So, थोड़ा सा sketch कर देना. That's good. Yes. And how to write it? Statement wise, I understand. And writing there is possibility that you might eat some words, you might not be able to orchestrate it better, but still, I'm just letting you know. पहले right hand thumb rule बताना है. You have to explain what is right hand thumb rule. It states if a point our right hand thumb in the direction of current, our fingers they show what? The direction of magnetic field lines. इतना ही है, right? Wrap around conductor in direction of magnetic field. Second, how it is useful? Direction of current through the conductor is given as vertically downwards. Hence, if we point our right hand thumb downwards, fingers will wrap in clockwise direction. Simply है ना? Yes. Nice. So this was a simple question. Next question. है ना? Next question. It's a 5 marks question. Right? It's a 5 marks question. Let's look at it. अरे simple था. I know. Nice, Hari Murli. Very good. Sukhjot, Kritika, thank you. Yes. Explain with the help of the pattern of magnetic field lines the distribution of magnetic field due to a current carrying circular loop. Now, if you ask me, do you know why this question is 5 marks? Okay. Yes, correct, Sukhjot, you're right. Nice, yeah, you have a good typing speed. I'm not able to type such fast. Alright, done in notebook, very good, Disha. Yes. Yeah, it's okay, Rupa. People get excited and they end up answering a lot more and it looks like spam. Yes, Kashif, that's also right. Come on. Okay. That's also right, Kavya. Nice. Yasharth. So you all are giving correct answers. That I'm pretty sure. It's just part by part. Someone is saying some part, some is saying some part. So don't worry. I'll just collate it together. Let's take a look at the first. Explain with the help of pattern of magnetic field lines the distribution of magnetic field due to current carrying circular loop. Diagram is important, guys. It's a 5 mark question. You should be showing to the examiner, what, I know this thing clearly. So, yeah, Shadab, take in note of. Nice, Hari Murli. Alright. So, circular loop, you will show the current because without this direction of current, it doesn't make sense where we are showing these concentric circles, right? So, if the current is this side, right? If current is this side, what you'll do? Thumb, fingers, thumb, fingers, thumb, fingers. So all this is telling me this is the direction of magnetic field lines. Alright. How to write it? At every point of a current carrying circular loop, the concentric circles represent magnetic field around it. That's true. You have given me this answer. Yes, diagram. You are right. It which becomes larger as we move away from the wire. At the center of the loop, these lines appear as straight lines. So you see, all of you gave me correct answers. It's just they were parts of this whole answer. है ना? So that's why if you make a diagram, maybe examiner might not read your answer properly. They would understand, हाँ यार इसको पता ही है. Fine. So that's why diagram. Good. इस perpendicular center line है ना? देखो center line क्या है कि we have seen this thing ना? All these are in the same direction. So in the center it becomes in the straight line. It joins and gives you a straight line. That's why. Right? So second one. Why is it that the magnetic field of a current carrying coil having n turns is n times as large as that produced by a single turn? Don't be confused with the language. I'm telling you again. Why is it that the magnetic field of a current carrying coil having n turns? A coil hai which has n turns. There is a coil which has n turns. Is n times. What n times? The magnetic field is n times as large as that produced by a single turn. So language ki jaal mein nahi fasna hai. Don't get trapped into this language loop. Hai na? Don't worry about that. Just read the question patiently. Right? Yes. Nice, Papia. So, magnetic field increases with magnetic field increases with increase in number of turns. Yes, Subjot, you are right. Sheetal, yes. Is it Sheetal? Alright. There's still time, no? In that. Yes, as the turn increases. Fine, nice. So the current in each turn has the same direction, and that's why the magnetic field due to each turn adds up. I think someone asked that question before, why it adds up. So that's the answer. Therefore, if there is a circular coil having n turns, the field produced is n times as large as that produced by a single turn. Statement kya bola? So yeah, Harimurli, I can see you have given a correct answer. Sheetal, nice. Yes, correct. So my suggestion is again, agar there is a diagram possible, if there is a diagram possible, make it. Because writing this answer nicely is little difficult, I understand. Maybe you might miss some important point, but diagram if you have made, it's good. Okay? Nice. Correct. Very good. Alright. Question number 11. Again, a 5 marks question. Do you see this pattern? This huge weightage questions are coming more in this magnetic effect of electric current. Hai na? 2 parts, 5 marks. Previous question also 2 parts, 5 marks. Hai na? Are. Yeah, Bhumi, please. Yes, proper art of writing answers. Is my throat? Yeah. Correct. Writing answers is an art. You know that. Yes. Tesla. All right. Nice. Okay. Solenoid. ठीक है. What is a solenoid? Draw the pattern of magnetic field lines of first a current carrying solenoid. Now you understand this, right? It is very important making diagrams, which means in solenoid, what is the similarity? It looks or it is similar to a bar magnet. Right? So, the reason this question is 5 marks is because the question is asking you to draw the diagram, and the examiner or the question knows making a solenoid, and making the diagram of these magnetic field lines is not that easy. it requires little artistic skills. That's why it is 5 marks question. Alright? Okay? Bhumi. In magnet, from which pole to which pole? Outside the magnet, it is north pole to south pole. Inside the magnet, it is south pole to north pole. So magnetic field lines always form a closed loop. Hai na? Bhumi, yeah, that is your answer. So this is the thing, plus minus. Now you should also know this. If you are writing plus and minus and you are making the magnetic field lines, you should know which side is going to be north and which side is going to be south, right? You should know that. And how would you know that? Here, current will go like this. So if you take the solenoid and look it from here, the current is going clockwise. Clockwise is south. From this side, current is going like this. So this is what anti-clockwise. If you take a look from here, it is anti-clockwise, right? Anti-clockwise is north. So that's why. This is important. Don't make mistakes. Because let me tell you, even if you draw a solenoid, even if you make plus minus, and you might make mistake where? You might make mistake in this direction. Galti se ye kar diya to? You can do that, no? So be very clear with this. Which side is going to be north and which side is going to be south. Got it? Nice, Harimurli. Yes, Sukhjot. Clock face rule. Nice, nice, nice. Alright. So diagram is fine. A coil of many circular turns of insulated copper wire wrapped closely in the shape of cylinder is called a solenoid. This is the diagram. You got 2 marks. Fine. Draw the pattern of magnetic field lines of a bar magnet. Okay. This is one more. This is also easy, right? This is quite easy. You'll just make a rectangle. You'll write north and south and you'll do this thing, right? And you know what? Maybe if you want, even if you show this dotted lines, that is also fine. Even if you miss, that is also fine. No one will cut your marks for this. Nice. Very good, Disha. I got it. Yes. Nice, Puneet. Sukhjot. So Disha, you are giving answers for Mobile Pura. Mobile Pura iron ho gaya. Yeah, I know. These sessions are long. Don't worry. We are done with the 4 more questions. Nice. Correct, Disha. You are on the right track with that answer. So, looks similar, right? Correct? Right, Rupa. You are also right there. Heating effect of electric current. Nice. So, you will draw the diagram. A bar magnet is always magnetized, whereas, so this is the third part. List 2 distinguishing features between the 2 fields. Now, I understand we have always, oh, sorry, Rupa. Sorry, I'm really sorry. I forget the names. Right? Yes. What is the answer? You have to find the distinguishing features. Till now, we have only heard about the similarities, right? But, oh yeah, Surya, my bad. So, here what do you have to find? The distinguishing features, which means solenoid and magnet. You know what? There is a safe ground you can touch. I would say don't go here and there. There is a safe ground. Solenoid needs current. It does not. You can change the magnetic field strength of this. You cannot for this, right? So that's why a bar magnet is always magnetized, whereas a solenoid is magnetized only when a current flows through it. Take. And magnetic field strength of a bar magnet fixed but can be varied for a solenoid. How? Current, number of turns, right? Yes. Horseshoe magnet, to ye hota hai na? This one, north, south. That is a horseshoe magnet. Right? So that's what I'm saying. Just follow these terms. Question number 12. Again, 5 mark question. Yes, Yasharth, we'll get them, don't worry. Nice, Rupa. That's also, sorry, nice, Surya. That's also a very good answer. That's correct. It can be changed, but for this bar magnet, you cannot change it. Nice, Rupa. So, oh my God. I think it's been 1 and 1 hour and 15 minutes, and I'm not in a very good state to take names right now. Hey Surya, yeah, you're right over there. So, yes, U-shaped magnet, Puneet, very good. So, again, do you see, one more 5 marks question, right? One more 5 marks question. So, you understand, or you can expect that, you know what, we are getting more marks question from the magnetic effect of electric current. Alright. Nice, Kavya. Sukhjot getting the answers. Session is 10 to 12 minutes more. Come on. Fleming's left hand rule. This one, what is this? खालिद, हिंदी में मैं कर सकता हूँ यार, बिल्कुल कर सकता हूँ. मैं इंग्लिश में इसलिए करता हूँ क्योंकि मैं चाहता हूँ मेरे स्टूडेंट्स कल फ्यूचर में दिक्कत ना हो उनको अपने कॉलेजेस में 11th 12th में, है ना. सो दैट्स व्हाई थोड़ा बहुत दिक्कत अभी होगा, बट डोंट वरी, राइट. सो दैट्स व्हाई. यस, नाइस सुखजोत. FBI, correct. Force, magnetic field and current, right? And every time, this is going to be current and this is going to be the magnetic field lines. And that is the Fleming's left hand rule. We use it to find the force on a current carrying wire in a magnetic field. Simple, right? So, now here, you know what? Here I would say it's okay if you don't draw the diagram. So I'll tell you why. Because drawing a hand is quite difficult. So what you can do is, you can do this. This is my magnetic field lines. This is my direction of current and this is my force. Fine. So this is an easier version of drawing the left hand rule. Okay? Right? Yeah, that you can also learn, Kavya, with. Correct. Hey. Arrow marks. So you can use this also, है ना? If you are not sure of how to draw a hand, because you know what, however hard I try, I cannot draw this diagram. So Nali, FBI, force, magnetic field line and current. If this is the direction of magnetic field lines and this is the direction of induced current, this will be the force, right? This is called as Fleming's left hand rule. It is used to find the force on a current carrying wire in a magnetic field. Fine. Now, the challenge is, yes, they are mutually perpendicular, Disha. Hello, Aditya. Yes, nice, Vasudev. You remember FBI, huh? There is MIB also, right? Yes. So, the reason I told you to draw that arrow diagram is because diagram is important in this question also. Because I understand if you try to write this answer like this, we might forget to mention something. So that's why make those arrow diagrams for sure at least and then explain it. Fleming's left hand rule states if we arrange our thumb, forefinger and middle finger of the left hand perpendicular to each other, then the thumb points towards force, the forefinger points towards direction of magnetic field and middle finger points towards electric field, electric current, right? Nice, Parul. That's a good and detailed answer. Rupa, FBI is what? F is for force, B is for magnetic field and I is for current. These are the symbols, na? Force, magnetic field and current. FBI, fine. Sorry, Surya, again, sorry. Nice, good detailed answer, Hari Murli, very good. Surya, you got that, no? So, working principle of electric motor, and Sukhjot has been answering this for quite a while, I see. Yes. Working principle is what? There is a force on a current carrying conductor in a magnetic field. That is the working principle, right? When a current carrying conductor is placed in a magnetic field, it experiences a force, direction of which is based on Fleming's left hand rule. So, this part was asking only about the principle, not the whole thing. But which part? Which part is asking about the function? Sorry. So, my thing is, my fear is to answer that B part, I would recommend not to go for the whole description, construction, working, everything. No need. I have seen students doing it. You don't want to do that, right? Okay? So that's why. Just focus on the principle, not more than that. It will be essay and not required. So that's why. Yeah, it's okay, Surya, don't worry. Simple motor, yes. Nice, Kavya. Hello, Shivam. So, armature, brush and split rings. So, armature is which one? Come on. Okay, let's start with carbon brush. So, I understand this is right. So, carbon brush, it is the contact between commutator and electric circuit. Brushes are fixed, right? Brushes are fixed. Then comes split ring commutator. It reverses the direction of flow of current through the coil. We need to reverse the direction, because if we don't reverse it, this motor will keep on doing oscillation like this, like this, like this, like this, right? So that's why A, B, yes, Surya, you are right. Yes. So just we talk about current only. That's why electromagnetic induction में आता है वो सब. EMF भी तो, see, if current is getting induced, there is an induced EMF also, na? So we just say it is induced current. That's why. Yes, Disha, correct. Yeah, you can think of it. I mean, like this, है ना? That is also happening. So, carbon brush, split ring commutator and armature. Coil wound on a soft iron core to increase power and rotates when a current is passed. So, this whole setup is what we are calling as armature. Okay? Yes, nice, Isharth. Harimurli, good. Kavya. Yeah, it could be, Kavya. And actually, you know what? It is. Most of the times. I mean, bar magnet it's not possible. So, you need the two poles which can be formed in such a manner that there is space in between. So, yeah, normally it's a horseshoe magnet. Thank you, Puneet. Nice. Very good, dear. You guys know all the answers. Nice. Armature. Rectangular iron core wrapped by the copper coil through which electricity passes, and due to magnetic field experiences force and rotates. Fine, right? But you know what? In this answer, if you draw the diagram of electric motor once, it will be very helpful. My suggestion to you. Just practice this diagram so that you can just at least draw a schematic. Hai na? So, oh, Surya, it's a whole different question. Brushes provide contact, split rings reverses the direction of current flow through the coil. 3 marks. Alright. Question number 13. Don't worry. This one is an easy one. It's a 1 mark question. Fleming's right hand rule gives what? And you know what? It's a poll question. Oh, revisiting all your concepts, huh? Nice. I want you to realize all these. So, it's a poll question and I'll give you 30 seconds. Your time starts now. Polls, huh? So after a long time, we have seen a 1 mark question in magnetic effects of electric current. Nice. Yes, Yasharth, you are right. Durvesh, okay. All right. Wow. What is the answer? Huh? C got 77%. Nice, very good, very good. Direction of induced current. We know this. If we know the left hand rule as FBI, we call the right hand one as MIB, right? Why MIB? This is current, this is I, this is magnetic field, this is B, this is the motion, right? It is the current induced because of motion of a conductor in a magnetic field. Okay? Right? So that's, and again, my suggestion is not able to, if you are not able to draw the hand, you can do this thing again. This is my magnetic field, this is my current, and this is my, and you know what, hand always helps. Oh, I want to draw this thing, right hand rule, okay, arrow, arrow, and this arrow, fine, you can use this. You can make the diagram like this also, not a problem. Priyanshu, all this is important. And don't worry, we are going to have a session where I'll tell you the strategy. Don't worry. So, Fleming's right hand rule gives direction of induced current. Alright. This is 1 mark question. Fine. The second last question, guys. Come on. We'll take just 5 more minutes. 2 coils of insulated copper wire are wound over a non-conducting cylinder as shown. And you know what? If you have been attending the previous sessions, we have done a similar question in that, right? Do you remember? Coil 1 has comparatively large number of turns. State your observation when key is closed. Oh, Papia, I won't tell you. I mean, no, just not the series. I think you got it, huh? I'll tell you in the end, don't worry. Yes. Menti, I don't prefer Menti because right now, I've told this to you before also. We want animations and that's why Menti does not have that feature. But we have polls on YouTube, na? Nice. Remember, huh? So, let's see. Concept is electromagnetic induction. We know that, right? Fine. When the key K is closed, what happens? As soon as you close the key, current flows, means there is a magnetic field generated in that coil. But this coil, what is electromagnetic induction? If there is a varying magnetic field to this coil, with respect to this coil, there will be an induced current. So, as soon as you turn the key on in this coil, there is a magnetic field generated because it's a solenoid, magnetic field will be generated, fine. Lekin kya ho raha hai? What is happening to this coil? It is seeing a change in magnetic field, induced current. But as soon as you turn the current on, there is a change, it will also see a change, it will think induced current will come. But then it is constant. But what does this need? The second coil, what does it need? It needs a varying magnetic field. So that is the important thing. When will we have an induced current? If we have a varying magnetic field, right? Yes, nice Disha, it's a good answer. Yasharth, nice. Nice, nice. There will be a momentary induction of electric current. So, first one, as key is closed, galvanometer needle shows deflection to one side. As key is opened, it shows deflection to opposite side. Why? In the first case, the current is flowing. There is a generation of magnetic field. There will be a current flowing. Then it is going off. So it will be in the opposite direction. ठीक है? विशाल, ठीक है, मैं समझ रहा हूँ. It's okay. देखो, guys, English I have dealt with. Give me just 1 minute. I'll explain in Hindi also. यहाँ क्या हो रहा है? जैसे तुम करंट ऑन करते हो, तो जैसे तुम की ऑन करते हो, क्या होता है? यहाँ पे करंट फ्लो होता है, उसकी वजह से मैग्नेटिक फील्ड लाइंस आती हैं. इसको क्या चाहिए? दूसरी कॉइल को इसको चाहिए वेरिंग मैग्नेटिक फील्ड लाइंस. यहाँ जैसे ही करंट ऑन हुआ, मैग्नेटिक फील्ड लाइंस आई, इसको करंट इंड्यूस हुआ बिकॉज इट वाज अ चेंज इन मैग्नेटिक फील्ड. नेक्स्ट, द मोमेंट यू टर्न इट ऑफ, व्हाट हैपेंड? द मैग्नेटिक फील्ड लाइंस आर गॉन. इसके लिए क्या हुआ? चेंज इन मैग्नेटिक फील्ड था, चला गया, इंडक्शन ऑफ करंट इन द ऑपोजिट डायरेक्शन. ठीक है, फाइन. So this was, I understand, language was important here, that's why. समझ में आ गया? चलो बढ़िया. Let's move forward. Answer. This is the effect, right? Electromagnetic induction. Current in coil 1 starts flowing when the switch is turned on. This change in current causes a change in magnetic field, and changing magnetic field induces current in coil 2. Fine. Second, current in coil 1 stops flowing when the switch is turned off. Current is stopped. Fine. This causes change in magnetic field and induces current in opposite direction. Hence, galvanometer shows needle in opposite direction. Okay. This was a very important question. when you turn the key on, it had a current induced, but in one direction. As you turned it off, there was an induction of current again, but in opposite direction. Okay? Yeah, Surya. See, I'm creating a balance. I have explained in Hindi also, in English also, this particular thing. I understand. This was important. That's why I did this. Alright? Got it? Fine? Nice, Disha. Sukhjot, good? Yes, electromagnetic induction. Last question for today. Again, it's a 3-mark question. Yes. I understand. Phone is dead, feeling tired. Last question for today. Don't worry. What would be observed if a strong bar magnet with its south pole towards one face of coil is moved quickly towards it? Now, guys, again, see, last question, put all your energy here in understanding the question. There is a coil of insulated wire, is connected to a galvanometer. Fine. What would be observed if a strong bar magnet, this is my coil, is moved quickly towards it, is moved quickly away from it, then held stationary near it. These are the 3 situations. पहले में जल्दी से पास लाए, दूसरे में जल्दी से दूर ले गए, तीसरे में बस रखे रहे. ठीक? ये है 3 phenomena. उसमें पूछा हुआ है. And you understand that. What does the solenoid needs? When will be there induction of current? If there is a varying magnetic field, and varying also how fast it is varying. So that's why. If there is a quick movement of magnetic field towards deflection in one side, quick movement on other side, deflection of galvanometer on other side, है ना? That's true. Second, held stationary, कुछ होगा? Will something happen? Nothing will happen. Fine, right? Clear with this, right? Relative speed matters. How fast it is changing. If it is quickly inside on one side, quickly going back on another side, stationary, 0, nothing will happen, right? Correct? Nice. Very good, Disha. Sukhjot, nice. Surya, good. Aditi, nice. So this is the answer. Half marks. Fine, right? All right. Name the phenomena involved. Come on. We just did this. Induction. What induction? Electromagnetic induction, right? Conductor moved in magnetic field or conductor placed in changing magnetic field induces electric current. You either move the coil or you move the magnet. It'll do, right? Nice. Good, Surya. Electromagnetic induction is the answer. Done. Next, state the conclusion based on the observation 1, 2 and 3. This is a big answer. This is where your energy will go. How? In case 1 and 2, galvanometer needle shows reflection due to phenomena of electromagnetic induction. This is clear. You saw the deflection because of electromagnetic induction. You just mentioned it. That is fine. Then, yes, Srishti, these are tricky questions. I understand. So I would say once this is done, you can just watch this small part of the video again. I understand. This last question is important. The motion of magnet with respect to coil produces induced current through the coil. There should be a relative motion. If there is a magnet, there is a coil. It cannot be non-relative motion. It should be relative. Something should happen. They should change, right? The induction of current will be different in both the cases. In case 3, there is no relative motion, and that's why it will not show any deflection. So, do you know what? What is the keyword? Relative motion. Fine. Nice. Thank you, Kodeshwari. Alright. And that's how we are done with all the questions. Oh, I'm also fine. Thank you, Kunal, for asking. Yes, Sukhjot. So, guys, you all know about All India Mock Board exams, right? This is for term 2. 12th to 30th is the registration. It is free, and I'm sure a lot of you have done this. And yeah, fine. Second, it is for classes 10th and 12th, CBSE and ICSE both. And oh, thank you, Kunal. Nice. Why? Today I won't tell you, don't worry. Come on. I think you are tired, guys. Come on. Nice, Hari Murli. Term 2, designed by experts, and so you know what is going to happen, right? You can basically give your exams, upload the image of your answers, and the panelists will evaluate them and tell you where exactly you made the mistakes. It's a good thing, so don't worry. It's a yes, free of cost, short videos. Register now, I would say. All right, and guys, we have got you covered. We are trying to get you covered, and thank you, Surya. The upcoming session is on last 50 days strategy. I told you, you were asking for motivation, tips and tricks. We will all do this here. Term 2 will meet again on Monday, 6 p.m. and we'll discuss our 50-day strategy to ace the physics Term 2 board exams. All right. Yes. Thank you, Disha. All right. And as Papia mentioned, the score boosters is coming. Don't worry. Stay tuned. From Monday onwards, we'll talk about score boosters. Papia knows this. You saw this in another session, na, Papia? Don't tell me a lie. Huh? Nice. All right. Then we have free trial classes, and you know what? Link is in the description. And the last thing I just want, I'll just tell everyone is like this video, because this was an important video. You will need to save this video, because I want, whenever you have problems in any of the questions, the last question especially, just save this video and watch that questions again. Fine. Like, share and subscribe. Simple. All I need. Right? Thank you. Practice, Srishti. Yes, we are looking into it. Don't worry. We'll give you. Alright guys, thank you for joining today, and you know what, we'll meet again on Monday. Bye bye.